Hi guys, welcome back to this concept-based YouTube channel. To all my dear viewers, today we will start exercise 5.1, and in the last lecture we have completed explaining the topics which is important for solving the textual exercise, and from today on we will solve textual exercise, that is 5.1 and 5.2. For our today problem, we'll solve question number 1 of exercise 5.1. Let us read. Which of the following statements are true and which are false? Give reason for your answer. And in the first part, we have only one line can pass through a single point, that we have to state it, why it is true. If first of all we have to determine it whether it is true or false, and after we determine it is true or false, then we have to give some reason about why it is false and how it is true, right? That's it. And let us move to the next, which is Roman number 2. In Roman number 2 we have there are an infinite number of lines which passes through two distinct points. We have to state this one, why it is true and how it is true, or if it is false, then we have to state the reason for that, right? Then likewise, up to Roman number 5 we have to state it, and after this our problem will be over. Then that's it for today, right? Now let us begin with the first things, that is only one line can pass through a single point. This word or this statement, you will be able to understand it just by reading this at once. Actually, in this, using 1 point, the statement is using 1 point, only one line can pass through that, right? But actually it is false. The reason why it is false, it is because, first let me take some point. This is a point, and the statement is only one line can pass through this point. Using this point, only one line can pass through this, right? But actually this is one line, but we can draw it another line from this side as well, which passes through this point. From that we can see that the statement is incorrect or false. If I want to draw in this side, then also I can draw it again, and even in this side I can draw it in this again, right? For this circumstance, the statement that we got in first Roman number, it is false, right? This is the reason why it is false. Let me write it. The first Roman number that we have, it is false. And the reason, I'll not write the reasons, but whatever things that I just explained it, in order to make you understand in this, that's the reasons for that, right? Then let us move to the next, which is Roman number 2. In Roman number 2 we have there are an infinite number of lines which passes through two distinct points. Two distinct points means there will be 2 points. These 2 points, actually according to the statement, these 2 points can be used to pass an infinite number of lines, right? But in reality that is not the case. Actually, using these 2 points we can draw only one line, this one, right? Not other than this. If you want to draw another line, then it may be like this, but it will not pass through this. Or if you start drawing from this one, passing through this, and then this will not be able to touch. So the only thing that is possible in this, it is using these 2 points or 2 distinct points, we can draw only one line. Thus, the given statement that we got, it is false again. Number 2, it is false. Then let us move to the next, which is Roman number 3. In Roman number 3, we have a terminated line can produce indefinitely on both the sides. And moreover, we can understand it from this Roman number 2 using postulate number 1. We came to know that using these 2 points, only one line can pass through them, right? Using that postulate, we can conclude that the given statement for this Roman number 2, it is false. Or the way how I explain it, that is also the reason for that, right? Actually, it is same, but one is called as postulate, and the one that the way in which I explained that, right? That's it. Then let us move to the next, which is Roman number 3. In Roman number 2, we have terminated line. A terminated line can be produced indefinitely on both the sides. Actually, with this one, we already studied in postulate number 2. According to the postulate number 2, if we have a line segment, let us suppose this is a line segment. Using this line segment, let me name it as A and B. Using this line segment, we can draw it an indefinite lines, right? In both the side, that is as well as in this side, as well as in this side. Using this terminated line or line segment, we can draw indefinite line which can be produced even in this side as well as in this side. That's it, what the statement actually means to us, right? Thus, this statement number 3, it will be true. Then let us move to the next, which is Roman number 4. In Roman number 4, we have two circles, and the two circles are equal if and only if radii are equal, right? We have a circle. In order to prove the circle is equal, the first thing that we need to know is that how much radius it is. If one circle has a radius of 5 centimeter and if the other has radius of 10 centimeter, which means they are not equal. But if their radius is equal, then the two circles are equal, right? So let me write it and explain it a little bit more about this. This is a circle, and let me name it, this one is radius 1, and let me suppose this radius 1 value is 5 centimeter, and again this one, let me name it as this one R1, R2. The values of R2, let me take it as 5 centimeter. But the radius are equal. If the radius are equal, means the whole circle, the circle that we have in this case as well as in this case will be equal, right? That's it. Then let us move to the next, which is Roman number 5. In Roman number 5, we have if AB equal to PQ and PQ is equal to XY and AB is equal to XY. Actually, this is the statement which axiom number 1 has given to us, that we discussed it like 2 or 3 days back. And in this case, the first line segment that we got it is AB, and after that we have PQ. Here we can see that AB is equal to PQ and PQ is equal to XY. Now, AB is equal to PQ and PQ is equal to XY. We can see that this PQ is common in these two. Using these two, this AB as well as this XY should also be equal to each other. That's what we call it. Things which are equal to the same thing are equal to one another, which is given by axiom 1. Thus, the given statement in Roman number 5 is true again. Let me write it. Okay, Roman number 4 is also true. And after that, we have Roman number 5, which is also true again, right? So that's it. I hope Everyone can understand this, and moreover, there will be no doubt in that. And I wish you all the best. Hopefully we'll see in the next videos. Thank you to all my dear viewers. And if you are new to this YouTube channel, please do like, share, and subscribe my YouTube channel for more videos to come. Thank you.